What is going on, everyone? We're eating some frozen. Get it? Frozen yogurt. Where's yogurt? But it's frozen. Okay. I don't know if that's cliche, but. Okay. Today's day 24. Day 24. We haven't missed a day. Doing good, man. Today we are gonna switch it up, and so my goal is to every time I learn like stacks, I wanna do like 2 or 3 LeetCode problems just to solidify me understanding what a stack does. I'm not trying to master it, if that makes sense. I just want to understand the concept of how it works, so when I come back to it, I'll be like, oh, I've done this before. Stack last in, first out. So it's just something that I wanna remember. So I did 2-3 problems now, kind of understand it. I'm of course gonna come back to it because I want to finish the NeetCode 150, and there's some problems on NeetCode 150 I haven't finished. So I don't know how much I did on NeetCode 150. I've done problems off of it too, so probably did like 3-4 problems of stack. I kind of understand. So we're gonna move on today. We're gonna do Q. We're gonna do Q. See if there's I believe there's a problem at the end. There is a problem at the end. Let me see. I know I'm not sharing my screen, so yeah. We're gonna do Q today. By the way, thank you for the guys for the support. We're at 75 subscribers, almost to 100. So it's getting there. If that makes sense. It's getting there. We're at what are we? Let me see if anybody commented here. Yeah, we got some comments. I responded already. Let me see. This one had more views. Already. Noah commented. Yeah, so I appreciate you guys for the support. We're at 75 subscribers, and yeah, man, we're doing pretty good now. Yeah, let's finish up Q's here. I got work in a bit, so I don't know how long today's video is gonna be. Alright. Let's get straight to it, man. What is a queue? A queue stores ordered items. A queue stores ordered items. Again, kind of like a list, but again, like a stack. It's designed more restrictive. A queue only allows items to be added to the tail of the queue, removed by the head of the queue. Okay, so the tail is right here and the head is right here. Okay, where does a tail and head start in data structures? Yeah, I'll just say that. Okay, so why is it saying that the head tail? What does it say here? Tail head. The fuck? What the fuck? Excuse my language, but that makes no sense. Let's add old-fashioned Claude. No. Oh shit. I think I misstep. Supposed to copy the clipboard, cancel here. Boom. This will go here. Here. That didn't work? Meh. Where? Oh my god, I always do that, brother. Copy, fucking. What is the correct way? I am confused. Looking at your images, I see confusion. Let me clarify the correct way to think about it. Head and tail and data structures are correct. We're not doing link of this. Okay, let's just keep going. A queue only allows items to be added to the tail of the queue. A queue only allows items to be added to the tail of the queue and removed by the head of the queue. It's already that you can append and then pop, right? No, if you append, it goes to this side. It's called queue because it behaves like a queue of people waiting in line in order for coffee. I see. I see. Okay. We have a video here. Yeah, you're not gonna get me this time. Let me lower down the volume. The first person to get in line is also the first person to be served. Get out of line. So you often hear queue referred as first in, first out.
Queues are one of those data structures that you probably already understand, even if you don't know it yet. Have you ever stood in line for 2 hours just to be told that Mickey had to leave and couldn't meet your daughter at Disneyland? Well, if you have, you were in a queue. You might already know about stacks, which are last in, first out, and queues are very similar, but they're first in, first out. Queues tend to be used way more often in the real world than stacks because they perfectly model so many real world systems. Amazon packages on a conveyor belt that my wife ordered for herself when I forgot our anniversary, that's a queue. People waiting for the new iPhone that has the exact same features as the last one, also a queue. The 69 bugs in your dev team's ordered backlog, believe it or not, queue. Whenever items are processed in the order they are received, that's a queue. Now, queues have 3 main operations. Enqueue, which adds an item to the back of the queue. Dequeue, which removes an item from the front of the queue. And peek, which reveals the item at the front of the queue without removing it. Now, that kind of sounds just like a Python list, right? And to be fair, it kind of is. But we actually are restricting ourselves to just these 3 operations. No iterating or searching allowed, which we could do with a Python list. But it's this same restriction that's what makes queues fast. Just like a stack, they can have order 1 time complexity both for enqueue and dequeue operations, assuming the implementation's good. That means queues stay fast, no matter how many items are stored in them.
Alright, makes sense. That's pretty easy. What is an example real quick? The set of possibilities of a game of dice? No. The sort of long line millennials without your, yeah, we did that. The lanes collection of total code? No. A stack of plates in a cafeteria? No. Okay. Queue class. Tailhead. Assignment. Locked in uses a queue to keep track of the order that recruiters should use to reach out to job seekers. Implement following operations on a queue class. Okay, this is already there. Push. So locked in uses a queue to keep track. Okay, so queue dot push item adds item in front of the list. Okay. So we do self dot push pop seek. Can't I just use append? What is the difference between push and append in Python? In Python, primarily adding an item as append. The term push more commonly associated with stack data source, versus adding an element on top of the stack. 4. Man, I'm using a pen, bro. Get off my DZ. Excuse me, sorry. Item. So we move the item. Then if we pop the item, right, we're gonna do self.pop. And then, oh, I just spelled that wrong. I just seen. Thank you guys for letting me know. Self dot peak. I think I did this wrong though. Don't this need parentheses here, parentheses here? Oh, do we return there though? We return self items, and then we'll do the size is the returns the number of items in the queue. So we can't just do the len return the len of, I don't like this, too many parentheses. Return the len of self items. I guess we have to use push. Adds an item to the tail of the queue. Oh, okay. Every time you add it, it adds it to the head. So the tail. How do you add it to the beginning? How do you add something to the beginning of a list? The append left? No way. That's fire. Wait, that append left shit is actually fire. Hold up. I guess you gotta push it, but can we push left? I don't know if this will work. I have no idea. Do I put it up here? Yeah. No, you have to have words in serial program. For example, here we're using push and pop, but NQ and DQ are also common words in the same ideas. Push and Q. Add an item to the tail of the queue. Pop removes and returns the item at the head of the queue. So this is right. I know this is right. But the underlying data type you were losing is just a list. Don't forget to guard against indexers if the queue is empty. The dot insert insert an item at a given position. Oh, the first item. Underlining words, don't forget to guard against index errors by returning none if the queue is empty. If so, the items the limit of the items is equal to 0, return none. But that, I think I should move this to the peak. That will work. Now we have an issue with this. I don't know how to do that. They're saying the dot insert helps. I don't remember doing this. An insert at any given position. The first argument in the index element, which insert a dot insert Bro, I don't know. I think I'm gonna just dot insert. What the fuck is a string? Is this a string? Oh, I'm tripping. No, I'm tripping. This not. No, hell no. Can I do like... How am I supposed to insert this in the beginning of the goddamn thing, man? Let's see how li dot insert 0 to 6 0 1 2 3 4. Explanation insert is used to add the value 6 at index 0. Holy shit. Ah. 0, and then we're adding the item. Self.peak. Oh fuck. Excuse my language. Self.item. Stop pop. That's on me. Peak. Dot. Self.items. Dot peak. Still got issue. So peak means we have to return the head of the queue. Alright, ran, push, mat, Q state, ran, pop, none. Both fell again. The pop is none. Q state. It's doing something right here. So it wants none. Don't forget to guard against indexers by returning none if the queue is empty. Oh, okay. Yeah, that's something that's this. Yeah, we gotta return none. The underlying data type we're using is just a list. Don't forget to guard against index. It has to be somewhere. Is it peak? I don't want to use GBT. I'm trying to think myself. Peak is pop none. The underlying data type we're just using is a list. Don't forget to guard against indexers by returning none if the queue is empty. Flip. If Q, how you spell Q, bro? QUEU, damn. Q is empty, how do you return? When the value in front of negative or value. I don't get it. Don't tell me the answer or show me any code. I would like hints and clues to my issues. How can we go back to being friends? But we just said, my code. Okay. Your super cool sensitive saying the pop returns none. Right now your pop okay. That's true. I didn't know it would put so if self dot self dot items okay, we'll do this the len which should be 0 return none, right? So peak your peak is so pay attention to the push and pop symmetry. Since push as an index 0, to tell the queue your pop should remove from the other end the head. Just make sure you're returning what you removed at the end. Doesn't that return from the end? I don't get this one. Pop returns none. Right now your pop method removes the item The pop method removes. Right now, the pop method removes the item from the queue, but it doesn't return anything. Think about what the list.pop normally does. It returns the item that was removed. Did he say pop return? Well, he never said. Oh. Sorry. That's me. Oh, God, I don't read instructions good. I'm tripping. This the head then. So basically, we're just gonna do this. Copy. Boom. Boom. We need to remove. We gotta return the head. The tail. Sorry, the tail. If we go here, if we print. Wait, dog. If I print. -1 does that. If I do 1, that should do 4. Yeah, so if I do 0, so it should be 0 returns that. So if I do 0, we got an issue. This is index range. Returns an item from the head of the queue. Oh no, man. Oh, the head of the queue. Bro, yeah, the head is right there. I know. I know. I don't get that. Push self item. This check prevents pushing into an empty queue. Shouldn't you be allowed to push the item first in an empty queue? Yeah, that makes totally sense. Why the fuck? Obviously it's gonna be empty. Oh my god, why do you do that? I think you gotta like be right here and do it, yeah. That's on me. Now the pop self. The pop. You're removing the item but returning the new last item. When you pop from the head, so why don't I just that we want to return wait, what? If it is empty, if len of self, the len of self dot items does not equal 0, or return self. One passed, one didn't. This failed. 2 equal this one. It's the pop, I know. If you're checking the queue has a len item does not equal 0. If it does, you return the last item, but you never actually remove it before returning. The self.items.pop line never gets reached because it's after the return. How the fuck am I supposed to fix it? Think about this. A real queue, you take the person in front of the line. You take the person in front of the line, and they leave. So you want to so you take the person in front of the line. So you want to remove the last item from the list, the head of the queue, and return that item. I have no idea how to do that. Okay. Okay. We pop that method. So now we gotta return what that item we just. I thought you show it and then you remove it. Like, doesn't that make more sense? Like, show the queue, the end of the queue, then you remove it. How do you remove it and you showed what you removed? I don't know how you show what you remove. I bet you'll pass all of them. Get your weird ass. Bonus clue that if in the push is still unnecessary, just remove that. It serves no useful purpose in push. Oh, you just said that if it's empty, then there's gonna be a problem. Okay, I understand. Okay, if I run it, last time this was correct, but yeah, now it's not. Okay, I understand, but how do I remove something at the head of the queue and then show what I removed? Don't I show it before I remove it? Imagine you're in a line at a coffee shop. The first person in line, the head of the queue, is Rand. You call next, and you see it's Rand. You remember the name. They say, Rand, you're up, and Rand leaves the line. You mark down Rand was served. So in close ones, you look at the item Rand. You remove the item from the queue. You return the item. So you print or use it in Python. I swear to God, in my head, I was gonna put it in a variable, and I would just remove the variable, return the variable. Wow, I should have just done that. I'm trusting my gut next time. So, remove is equal to self.pot return remove. And by the way, I did not know you can do that. Fudge. What? Oh, if it's empty list. I know that that's an issue, but then how's that an issue? Bro, do I have to do this for each goddamn... Whoa! Holy moly. I did not know that. See the solution. Okay, so push self dot insert 0 to item. See, that insert I've never known in my life, which is cool. Now I know. Pop if is equal to the same shit I did. Temp is equal to delete self dot temp return temp. I think that's too much for pop. This -1 was very easy. Just put in a variable and delete is crazy. Okay, it's just pop here, return temp. So peak is if len. Yep, same shit, bro. And then do -1, return the len alarm. Very similar, very similar, except pop is just a little bit weird, and I don't know why the push you need it here and he worked it out right here. That makes no sense. But all right, let's move on. Dang, I gotta get ready. Okay, I actually gotta go really soon. Let's see what questions. This one I can solve. This one I can do. This one, the end one is matchmaking queue and locked. Okay, let me see if I can hurry up. Corners to 10 minutes. Okay, I can try my best. Okay, queue speed. So how fast are queue operations? Well, in optimized queue, they'd be big O of 1. Add the items to the back of the queue. A queue. Just like stack, all operations are 1. The reason why the reason to choose a queue over stack is all about ordering. Used when you need to process items in the way they added LIFO stack versus FIFO queue. A problem. Our current queue class has a problem. Take a look at the push method. Self the items that insert 0 to item. Right. It's not O1. The list insert method has to shift all the items in the list down to make room for a new item. Right. Insert onion in queue. Tail head. Tail. Now you gotta insert onion in the queue, so that has to be in the front. So we have to shift everything there. We'll solve this very solvable problem soon. Damn. What did back on the push pop? It's O1. Damn, that's actually something that I didn't realize. When you insert the item in the tail, then you have to shift everything to the right first. That's something you gotta be curious about. Queue speed. An item could be anywhere in the queue. What is the big O company to retrieve the item? Oh, and why is our list based queues push operation? Wait, why is our list push? What? Oh, and because you have to search for the perfect insert item. Because you have to remove everything from the queue before. No, you have to move all the elements over by one index to make room. Yeah, it has to be this. Okay, I'm gonna save this problem. I think I'm gonna do this on my own. When we come back, we'll go on the Necode 150 and work on it there. So yeah, it seems I'm connecting the dots. I think stack and queue have very close similarities, but depends when you want to use stack and then when you want to use queue in certain situations. But yeah, getting better, guys. I appreciate you guys for watching this video. If you learned something new, comment down below. And I appreciate all the support you guys have given me and the motivation. So, thank you guys. This was day 24. All right, guys. See you guys tomorrow.